A pollution dome is a phenomenon where pollutants, such as smog and particulate matter, get trapped in the air above a city or industrial area, forming a dome of pollution. This occurs when weather conditions, such as temperature inversions, prevent polluted air from dispersing, leading to an accumulation of harmful substances in the atmosphere over time. Pollution domes are especially common in urban areas with high levels of vehicle emissions, industrial activities, and limited air circulation. 10 causes of pollution domes. 1. Temperature inversion. Temperature inversion is a weather condition where a layer of warm air traps cooler air, and pollutants, below it, preventing pollutants from rising and dispersing. This leads to an accumulation of smog, creating a dome effect, particularly in colder months or at night. 2. Vehicle emissions. High levels of car and truck traffic release pollutants like carbon monoxide, nitrogen oxides, and hydrocarbons. In dense urban areas, vehicle emissions accumulate in the air and contribute significantly to the pollution dome. 3. Industrial emissions. Factories, power plants, and other industrial activities release pollutants, including sulfur dioxide, nitrogen oxides, and particulate matter, which can accumulate under certain atmospheric conditions and form a pollution dome above cities. 4. Urban heat island effect. Urban areas are often warmer than surrounding rural areas due to heat from buildings, cars, and infrastructure. This urban heat can create localized wind patterns that trap pollutants in the air, intensifying the pollution dome. 5. Limited air circulation. Geographical features, such as valleys and mountain ranges, can limit air circulation, trapping pollutants within urban or industrial areas. For example, cities surrounded by mountains, like Los Angeles, are prone to pollution domes due to limited airflow. 6. Construction and dust. Construction activities, including demolition and road building, generate significant amounts of dust and particulate matter. These particles can accumulate in the air, contributing to the pollution dome, especially in areas with ongoing construction projects. 7. Burning of fossil fuels. The burning of coal, oil, and natural gas for energy production releases large amounts of carbon dioxide, sulfur dioxide, and particulate matter. Areas heavily reliant on fossil fuels for power generation, like coal-fired power plants, often see significant contributions to pollution domes. 8. Use of chemicals in agriculture. Agricultural activities near urban areas release pollutants like ammonia and pesticides, which can add to the pollution dome. These chemicals can drift into urban centers, especially during periods of low wind, and worsen air quality. 9. Household emissions. Indoor heating and cooking, especially using solid fuels like wood and coal, release pollutants into the air. In densely populated areas, these emissions accumulate and can add to the pollution dome, particularly in colder climates where heating is necessary. 10. Stagnant weather patterns. Certain weather patterns, such as periods of high pressure, create conditions where there is little wind, preventing the dispersal of pollutants. These stagnant conditions can lead to a buildup of pollutants, worsening the pollution dome effect. Here are the effects of pollution dome. 1. Respiratory and cardiovascular health issues. Pollutants trapped in a pollution dome can lead to respiratory problems like asthma, bronchitis, and other lung diseases. Fine particulate matter, PM2.5, and other pollutants can also increase the risk of cardiovascular diseases. For example, people living in areas with high pollution domes often experience higher rates of asthma and hospital visits for breathing issues. 2. Increased mortality rates. Exposure to high levels of air pollution can lead to premature deaths, especially among vulnerable groups like children, the elderly, and those with pre-existing health conditions. Long-term exposure to pollution domes has been linked to increased mortality from respiratory and heart diseases. 3. Reduced visibility and smog formation. Pollution domes often lead to smog, which reduces visibility and gives the air a hazy, yellowish look. Reduced visibility can affect daily life, as well as road and air travel, leading to delays and accidents. Smog also affects the aesthetic appeal of cities, potentially deterring tourists. 4. Soil and water contamination. Pollutants from the dome can settle on soil and water surfaces, leading to contamination. For example, toxic substances like heavy metals may accumulate in the soil, affecting agriculture and potentially entering the food chain. Water bodies can also become acidic, harming aquatic life. 5. Acid rain. Pollutants such as sulfur dioxide, SO, and nitrogen oxides, NO, in a pollution dome can combine with water vapor to create acid rain. Acid rain damages buildings, historical monuments, soil, water bodies, and forest ecosystems, leading to long-term environmental degradation. 6. Climate change and greenhouse gas accumulation. Pollution domes often contain greenhouse gases like carbon dioxide and methane, which contribute to global warming. The dome effect amplifies the local heat, adding to the urban heat island effect and exacerbating climate change impacts in the region. 7. Harm to plant and animal life. High levels of pollutants can damage plant life, reducing photosynthesis, stunting growth, and making plants more susceptible to disease. For animals, polluted air and contaminated water sources can lead to health problems, reduce reproduction rates, and disrupt local ecosystems. 8. Economic losses. Pollution domes lead to increased healthcare costs, decreased worker productivity, and damage to agriculture and fisheries. Businesses may also incur additional costs to comply with environmental regulations, and tourism can decline due to reduced air quality and visibility. 9. Psychological and mental health effects. Living in a heavily polluted area can lead to psychological stress, anxiety, and a reduced quality of life. Studies have shown that air pollution exposure can also affect mental health, contributing to conditions like depression and even cognitive decline. 10. Erosion and damage to infrastructure. Acidic pollutants in the air can corrode buildings, bridges, and other infrastructure, especially structures made of metal and limestone. Over time, this can lead to higher maintenance costs and the need for more frequent repairs, impacting the economic sustainability of urban centers. Strategies to reduce the effects of pollution dome. 1. Promote clean public transportation. Encouraging the use of electric buses, trains, and low-emission vehicles can help reduce pollutants from traffic, a major contributor to pollution domes. Cities can also expand public transportation networks to reduce the number of private vehicles on the road, which lowers emissions. 2. Implement emission controls on industries, requiring factories and industrial plants to use filters, scrubbers, and other pollution control technologies can significantly reduce the release of harmful gases and particulates. For example, installing scrubbers on smokestacks can capture sulfur dioxide before it is released into the atmosphere. 3. Encourage renewable energy sources. Shifting from coal and oil to cleaner energy sources like wind, solar, and hydropower can reduce the pollutants that contribute to pollution domes. Governments can offer incentives for renewable energy adoption to help accelerate this transition. 4. Enforce strict air quality regulations. Governments can set and enforce air quality standards to limit allowable pollutant levels. For example, establishing limits on emissions from vehicles and industries can help manage the amount of harmful substances released into the air, thereby reducing pollution dome effects. 5. Increase green spaces and urban forests. Planting trees and creating green spaces in urban areas can help improve air quality by absorbing carbon dioxide and releasing oxygen. Green spaces can also reduce the urban heat island effect, which contributes to pollution domes. Trees and plants act as natural air filters and cool down the surrounding areas. 6. Implement smart city technology for monitoring. Smart technology can be used to monitor air quality in real time, allowing city officials to respond quickly to pollution peaks. For instance, installing sensors throughout a city can track pollution levels, and when they are high, authorities can issue alerts and advise residents to reduce outdoor activities. 7. Encourage electric and hybrid vehicles. Transitioning to electric and hybrid vehicles reduces emissions from the transportation sector, a significant source of urban pollution. Subsidies and tax breaks can make these vehicles more affordable and encourage consumers to adopt greener options, helping to reduce the pollution dome effect. 8. Regulate agricultural and construction dust. Dust from agricultural activities and construction can contribute to pollution domes. Governments can implement policies requiring dust control measures, such as water spraying or planting ground cover, to minimize dust emissions in areas near urban centers.